So, we are going to talk about our experience with a big project. We think that with a technological perspective, this project was not very difficult, but it is something, a very common use case in almost every company. So here, we are talking about one of the biggest banks in the world, a tier 1 bank called BBVA, and that we were doing was a data lake for logs recollection. And this is something very well that we are finding in a lot of different companies, especially big companies. And this is the starting position in those companies. Normally, you have a lot of data, different types of data, and you have multiple log management solutions. So it is something like isolated data silos working in the company. And also, more of the solutions that you have for log management are writing to files, to hard disk, and then sending the file to this log solution, and then you can start to do things. So almost all the solutions that are in the market now and that your customers or any big company is using are not real time. And this was one of the first things that we wanted to solve for this big bank. So it is not only a data lake, a big data lake for logs. It is to facilitate the real-time analysis of the data that is entering in the system. And this is something quite peculiar, and these were some of the drivers of the project. Normally, when you are thinking about logs, you are thinking about data machine or data that is not that useful. But really, as you can see here, some of the drivers, of course, were security, regulatory compliance, because you have to keep the data for 5 years, or fraud detection. But it was like a surprise that a lot of business areas wanted the data that was inside the logs. For example, the data that was in the application's logs in order to analyze behavior of real customers. So they were getting data, customers' data, from inside the application logs. So the different drivers and use cases of a big data log system with near real-time capabilities are huge. So you can extend it just thinking and using your imagination, almost to any use case. This is the solution. It's a conceptual solution, as you can see. So that you have is multiple sources for ingestion. And then after this, you have to normalize the logs. Normalize the logs is something very difficult to do, because we are talking here about more than 2,000 different logs and applications. But there are some steps that are pretty easy. For example, the first one is to give some common data to all the logs. Timestamp, the machines that the log is taking the data from, and the applications. And this is like something very basic that all the logs that the system is receiving has. So normalization of logs. And after this, you have the data sinks. And as you can see here, the use cases are more than the normal ones. So at the end, you have different data sinks. And this is the solution. As you can see, well, the solution is a very normal one. There were some lines and rectangles here in this drawing, but I don't know why they are not any longer here. I can assure you that they are here. So anyway, the solution is very simple. That we were using was syslog to get the data, and we will see what are the syslog ng capabilities for near real time. After this, we were using Kafka. And from Kafka, we were sending the data to Sparta or to the sinks. As you can see there, we were combining Elasticsearch plus HDFS. We will describe the elements of the solution, and on top, you have a Spark with a Spark SQL. At the beginning, it was supposed we were using Tachyon, but we have replaced Tachyon with Sparta. Tachyon, we designed the solution to use Tachyon on top to be able to have the data from the logs here, like in memory in a cached system, and to aggregate or make analysis using Tachyon. But this element in Sparta that we are doing is real-time aggregation previous to store the data. So as we are aggregating and creating dimensions in real time, there is no need to make calculations in a cached layer. So there were any need at the end to use Tachyon in the solution. I will explain each one of these elements. So the software pieces, and this is something also very peculiar. We are using syslog ng for almost all the machines, but there were some machines, and this is something that for sure you will find in the big companies, that were so old that it was not possible to use syslog ng. So for those machines, legacy machines, we had to use a normal syslog with files, and then to send these files or logs with syslog to a syslog ng relay. And from that point, the architecture, the solution was the same one. But at the beginning, it was very difficult for these legacy systems with very old operative systems to get the data. And the third way is that the new applications are delivering the events, the messages from the logs directly to Kafka. So there is no need to go through syslog ng. Of course, we are using Spark with all the capabilities. As the use cases are, there are several use cases. Spark, well, was the perfect solution. In fact, in our company, we are only using Spark. We are not using Hadoop for any processing. So as you can see here, for batch, for interactive, for analytics, for streaming real time, and for machine learning, we are only using Spark. So one stack to rule them all. And this makes the solution very simple. Just to compare, imagine you choose the Cloudera distribution. There you could or would have to use Hadoop MapReduce for batch, Impala for interactive, and Spark for streaming or machine learning, so 3 engines. And 3 types of experts to develop and to deploy the system, and a lot more complex. With just using Spark, it is much simpler. You don't need any more. We will see the figures, and it is a perfect solution. So just using Spark. And this is our first advice. Well, the log collection, I have talked a little bit, but the point here, as I said, this is a near real-time solution for logs, big data lakes for logs. That we are doing is syslog ng is getting the events and sending all the messages from the applications directly to Kafka, to the network. So we are receiving any message, any event in near real time. With this, we can do things like fraud detection or real-time analysis. The logs, maybe I think they are the first source of data in a company. Even you have some data first in the log, and after this, in the operational databases. So to have a log system that is able to analyze the logs in near real time is very handy. Well, the log distribution, we were using Kafka. We have and we tested several different buses, and Kafka, like RabbitMQ or other solutions, and Kafka was the only one able to handle the throughput of the system because, well, you will see the figures at the end of the presentation. There were a lot of data, and RabbitMQ was not able to support it. And also with Kafka, that we are doing is getting topics, different topics, and Kafka is also able to aggregate, enrich, and make small transformations, and to generate other topics. So really, Kafka is one of the core technical solutions of the project. For the log storage, we were combining Elasticsearch plus HDFS with Parquet. We love Cassandra, MongoDB, HBase, all the different NoSQL databases, and we have integrated Spark with those NoSQL databases. But in this project, in a lot of different projects, HDFS plus Parquet is a perfect solution. No need to complicate things more. So we are using Elasticsearch in order to facilitate test search, because Elasticsearch is indexing the data and is incredibly fast to load to search test. But the raw data is in HDFS. So here you have a combination, and you can look tests or even make drill downs, any type of operation that you could imagine. It is a perfect combination. And well, as I explained, the heart of the system is this module. In this module, we are using Spark Streaming to get the data that we are receiving from syslog-ng in near real time, and to make real-time aggregation. So I will let David to explain the module, because he's the creator of this solution.
So we at STRATIO, we have done several projects with real-time analytics based on Spark and Kafka and Flume, or even Cassandra or MongoDB. And these technologies were always a perfect fit. We think so, but we found ourselves writing the same pieces of code over and over again. So we think that it should be a best way to do this kind of real-time aggregation. So this is how Sparta was born. And we studied several initiatives trying the same kind of problems, but such as Countandra, for example, or Rainbear from Twitter. But until now, all of them were complex, or they are obsolete, or even they are not open source. So we created Sparta, which is an open source and full feature platform for real-time analytics based on Spark streaming. So this is why we created Sparta. Our goals for Sparta is pure Spark. As I said before, we are using only Spark streaming. One important goal for us is that there is no need of code anything for doing this kind of aggregations. So Sparta is a declarative engine. And of course, we take all benefits from Spark streaming. So we are high performance and scalable and fault tolerant, of course. A first look about Sparta. You can define the aggregation policy in a JSON file. So you can choose which input do you want for the events. You can choose from every Spark streaming receiver. So we are compatible with all the Spark streaming receivers, such as Flume, Twitter, or Kafka. And then you can apply some transformations to the events. We are using Kite SDK for the transformations. And then you define what aggregations do you want to do with the data. And finally, you choose which output, one or many, do you want the aggregated data to be stored. So you can choose from MongoDB to Cassandra to Elasticsearch, for example, or HDFS. You can run several aggregation policies with Sparta, so you can start or stop anytime different policies. For example, one taking data from Twitter, or taking data from Flume, directly from Flume, or from Kafka, for example, and doing different aggregations in each workflow. As I said before, we are compatible with any input of Spark Streaming, and we are working with these outputs, MongoDB, Cassandra, Elasticsearch, or HDFS. And we can integrate more outputs or inputs using the data frames API or RDBs directly. So your aggregation policy must define where the data is coming from, which is the input, where should the aggregate data be stored, which is the output. This can be one or many. Which dimensions do you have in your events? Which cubes or rollups do you want to aggregate? And which transformations should be applied before the aggregation? So you can parse the event, for example, or enrich the event, adding more fields, or applying some data cleaning functions, for example. And the aggregation policy also allows you to choose if you want to save the raw data or you want to discard the raw data or only store the aggregated data. So we have some math operators for the measures, for example, max, min, or sum, or average, for example. And you can apply time-based operators for the aggregations. For example, you can aggregate by minute or by second, by hour. And you can apply even geo-range operators on the rollups. So you can group the data by ranges based on the geolocalization of the data. As I said before, we have integrated Kate SDK in order to do all the transformations to the data. So you can, for example, these ones are examples. You can apply the GUIP of the event, for example, or parse the event from Avro or JSON, for example, or applying regular expressions to the event in order to get the fields.
Well, the conclusion at the end, we are talking about one of the tier 1 banks, and these are some of the figures. At the end of the project, we will be handling more than 2 petabytes. So this is a very big solution with Spark in production, more than 200 servers. In fact, it will be about 400 servers working with Spark Streaming and Spark SQL. Streaming 11 terabytes per day. The system is really very with high scalability, so we can go from the 2 petabytes to any data that we want in the future. And as I said at the beginning, with real-time aggregation, that you have is real-time capabilities for log ingestion. And this is very new. I'm sure you will need it in most of your customers. So thank you. And any question?
So we're running a little bit short on time, so can the next speakers can set up? We'll take one question, maybe.
What were you using before this Spark? What was your system before? For all this, what were you using? What was the platform?
What they were using before?
Yes.
Well, they were using different systems for logs, the typical commercial solutions like Splunk or any of these solutions. So in any company that you are finding a commercial solution with no real-time capabilities or silos, data silos, it is susceptible to transform this into a big data lake with this type of capabilities, because Splunk, the technology is second IT generation, it's not third IT, so it is very limited.
Okay, let's thank our speakers one more time.
Thank you.